it's not the prettiest of days out there, so we appreciate you coming down and enjoying this talk with us and having some pizza. My name is Daniel Huster. I'm an engineer here at the DEC, and today I'm going to be talking to you about how to teach a machine to learn the .NET way. It's actually a talk that's going to be, hopefully, I've got two goals in mind with this one. First is to kind of share my experiences with machine learning. I'm completely new to machine learning before I started kind of going down this path. Obviously, I've heard the buzzwords, like some people have heard of, oh, machine learning, it's taking over the jobs, and it's going to do amazing things, and it is doing some pretty amazing things. But outside of that, I had very limited exposure outside of a couple of the deck talks that we've had here, done by Cody Hutchinson and others. So before I get started, I'm kind of interested in who all has heard of machine learning, at least on some level. Okay, that's pretty much all of us. Great. And I'd like to kind of know who would consider themselves kind of engineers, whether it's data science or otherwise. Okay. Designers. Okay, got a handful of those. And individuals that would consider them part of like business or product management. Okay, great, awesome. So this type of talk is not going to go in super depth to technology. That's not the goal of this talk. I'm going to kind of show a little bit of like what a program .NET sort of looks like. It's a really short program, but it's more to kind of get us all familiarized with this machine learning, like kind of just enough to understand what's kind of going behind the scenes, so that we can each make informed suggestions or start thinking like, what can we use this technology for? Because it's not going to go away, and it's only going to be a tool that we can use to really take whatever product we're working on, the business into this next century. So with that, I'm just going to start off level set. I am pretty new to machine learning. And I hope that that is something that you all can take away from this, is like, this is something anyone can jump into. I did get to work with one of my colleagues, Eric Johnson, and we kind of worked through this problem as we were learning this new technology. And I think it's important to any type of technology that we kind of have some sort of understanding for it. So the second part of this is I'm going to be introducing a little bit of Microsoft's ML.NET framework. Again, I'm not trying to say this is the framework of the future, but I'm hoping to, again, present something that's a little bit different. Because the truth be told, in machine learning, Python, its libraries are key. It's really, really well done. But there are some things that ML.NET can provide us. So, for those that have not been to one of the talks, I'm going to briefly kind of go over what machine learning is. I was watching a video by Google's Josh Gordon. And he gave kind of a succinct statement of what it is. It's essentially algorithms that learn from examples and experience instead of relying on hard-coded rules. So, as an example, because I'm an example guy, I like to see things, he was kind enough to go into an apple versus orange example. So, let's say my product manager comes to me and is like, look, we're really hearing our users are saying, I have to know the difference between an apple and an orange. Like, when I give them an image, it's got to be able to tell me because it's important to me. So, in the normal way of doing things, where previously, without doing any machine learning, I might write hard-coded rules. So, if I'm getting an image, I might say, okay, how many pixels of this is orange? How many pixels of this is red? And depending on that, I'm going to make a guess that one might be an apple, one might be an orange. Well, you can kind of quickly see where this will start to fall apart, because apples aren't just red. Apples are green, they can be yellow, they can be a combination. And oranges, well, I mean, depending on the brightness of it, might not be all that orange. So that can fall apart. But if I even get into that mode of, okay, I'm going to cover all these examples, maybe I even throw some computer vision libraries in there. I'm like, okay, I'm going to check the shape of this orange versus the shape of an apple. Okay, now which one's going to be it? Well, what happens if we get an image where there is no apple or orange in there at all? Maybe there's a banana in there. What happens at that point? And what we can end up with is a really, 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 really long list of hard-coded rules that, for those engineers out there, understand it's very hard to maintain, and it's not very helpful when something changes. On the flip side of this, if we came from the perspective of what machine learning proposes, is we can provide an algorithm a list of data sets and then let it kind of learn on its own. So what that would look like is maybe instead of giving images of apples and oranges to the machine, I give it a data set of maybe the weight and the skin texture. Apples generally are smooth. Apples generally weigh, let's say, 100 grams, whereas oranges might be 125 grams and be a bumpy texture. And then I provided this data set and train it, and so then I can provide it random data, maybe like here's a fruit that might be bumpy or smooth, and it has 115 grams. And then the program just says, okay, I know many things like oranges kind of fall into this area. I'm going to predict that this is an orange. And these models can get very, very sophisticated very, very quickly. One of the absolute best benefits of it is this type of program can be very short and small. Like it can be very concise and it can be transferred. So I give them an example of what apples and oranges look like, but what happens if I wanted to provide a data set that had numbers of tires and fuel type, and use that to determine whether or not something is a car or a truck. I didn't have to change much from my program's perspective, but I'm getting something that is also useful. Hopefully, that kind of is a little bit of a baseline of the difference between the hard-coded nature and the experience, learning through examples and experience. And I'll show just a little bit more of that, and hopefully make it a little bit more clear in the example later. So why did I choose ML.NET to learn? Well, first, again, as I said, Python is pretty much the key. It's a very well understood, most data scientists point to that, and it's got a lot of great libraries behind it. So, but just knowing that one area kind of confines us and doesn't really show us where things could potentially go. So some of the nice things that I liked about ML.NET when we jumped into it is first, it's open source. Most of the libraries from Python are as well, but this was a benefit. So you can go onto GitHub right now and see what code is going into this, what type of traction, what things are changing. It also is part of .NET Core. The benefit of that is it can run on Mac, Linux, and Windows. Linux being a big bonus because a lot of the cloud runs on Linux servers, so now we have access to that computing power. Another big benefit is it works with the current .NET framework. So if you have an ASP.NET application or an ADO.NET, you can start to really leverage some integrations with it. That can be very helpful. Also, if you're not a fan of Python, you could write it in C#, F#, and VB. So in this case, both Eric and myself, we were familiar with C#, so it made sense. The other nice thing that I was encouraged by is development is ongoing. In the process of learning it, they actually released the .9, so we got to experience transitioning our code from .8 to .9 support. So it's not out of beta yet, but it's on the roadmap. And what's happening is a lot of the frameworks are just tightening. They're finding, okay, this is something that's easier for developers, this thing makes more sense, and that's kind of the change that's happening right now. But there are features being added. And the last one is the documentation and examples. Because while we were learning this, we also looked at MLKit by Google, so MLKit and TensorFlow. And it was fine, but it was actually kind of hard to follow. And so reading through the examples, it wasn't clear as much of like what was happening. It was almost kind of like black magic. Whereas with the examples with ML.NET was a little bit more descriptive. Like, this is what it's doing, this is what it's happening. And there just seemed to be more helpful examples. So that was something that we really enjoyed as we were going through this. With that said, .9 is also kept up, they kept the examples up, the documentation is still catching up, so there might be a couple of things that are still out of date, but it's definitely transitioning to the documentation. So before I get into the example, which I'm about to bring up, the code example, there's three little terminologies I'd like to present, just so that that barrier, we can just jump over that barrier really easily. The first is a classifier that you might see in there. The short and simple of that is that a classifier is essentially it takes data in and outputs data. And that data is what they call features. So the example that I gave previously of the weight and the skin texture of a fruit would be a feature. The more features you have and the more clearly distinctive they are, the more helpful it is. Because there's a lot of features that aren't very helpful. And that's part of the science of when you pull in your data to find, okay, like, is this going to be useful for what I need? And I hope to show just a little bit of that in the example. The label is what is the output. So an example of the apple and orange, maybe is it an apple or is it an orange? Or the example of the truck and a car, is it a truck or a car? Another example is if you're trying to predict taxi fare. So maybe your output would be in that point, whether or not you're going to pay $10 or $15 based on distance. And let's see here. So hopefully that gives a quick overview, just three of the terms you might see in this before I jump into this. So before I jump into the example, is there any questions? Okay, I'll jump right into it. So a little bit of a play of where we're going. So in learning this, we decided to pull in the data set of the Titanic. It's an actually pretty useful data set, and it's something that a lot of beginners might use to start learning machine learning because it's pretty straightforward. In our case, we were looking at who survived and who didn't. And so that is a well understood set of data. There's also a lot of data around those, like how old the passenger was, what was their fare that they paid, what was their ticket, what was their cabin number, what was their sex, what was, there's a number of other opportunities that you can pull in from the data. So there's like a lot of data that you can potentially pull. And the challenge there is to say, can we come up with an algorithm, a machine learning algorithm that can accurately predict whether or not someone survived. So this is actually it. This is the whole program with ML.NET. It's 100 lines, essentially, if you take out the comments that I have in here. So there's not much to it. But if I was to write this program with hard-coded rules, this is going to be much, much longer. So I don't have to worry about that. So the first part is I'm simply going to be building out a model, and then I'm going to test a prediction against that model. First thing I have to tell when I'm loading my data is what type of data I'm coming in with. So there's the passenger ID, whether or not they survive, their name, their age, and again, we can kind of see some of these things. Some of these things may or may not be useful to my prediction. Maybe it doesn't matter how many siblings they have, or maybe it does. Maybe it doesn't matter whether or not what their cabin is, or maybe it does. When you look at the Titanic, I got an opportunity years ago to go to a Titanic display in Lexington. It was really cool because they actually had done a lot of research on this, and just some rules like they found is that if you're female and you're younger, you had a much better chance of survival, unless of course you were at the lower levels. And so at that point, your chance of survival drops significantly. But that's all I'm doing here is I'm taking in our data sets. And these data sets, I have two different sets. There's a training set, and then there's a test set. So the training set is what I'm going to use to generate my model. This is just a comma-separated file. So at the top here, you'll see what the labels are for each one of these different columns. If you load this into Excel, it'd be a little bit easier to read. And then I have a test set, which I'm going to run those predictions from my test set against the model I create. And that's how I can tell what the accuracy is going to be. So I load the data set, and I create a pipeline. The pipeline is essentially a way to clean up the data and put together the things that I want to start to make my prediction. In this case, I'm worried about whether or not they're surviving. And to keep it simple, I'm checking to see what their sex was, what their age was, and what they paid for their fare, just to see what's different there. Now, what you'll notice here is I have when we're cleaning up this data, you might see something like one hot coded. The way machine learning works behind the scenes is it does everything through a binary lens, a number lens. So when things are strings or text, we have to translate those. Fortunately, most libraries have the capability to do that for us very easily. And then you are given the opportunities to normalize values. I did a couple of normalizations here. At the end of the day, it didn't really affect the results that I had, but you might be able to find some places where it would. And then I use that data to generate my features, which I had talked about previously. At this point, I am using what I would consider a pretty good example for the pretty good trainer for this, which is binary classification. In machine learning, there's generally 4 different types of known and heavily used types of learning algorithms. There's like a classification model, which is what we're using today, which would be whether or not something was like an apple or an orange, or in this case, whether you survived or you didn't. There's other ones like regression, which might be more of like your fare, taxi fare, and then there's a couple others. And I'll show a little diagram of what that, a little cheat sheet, if you will, to help you kind of decide what you're looking for. But in my case, it's very binary. You either survived or you didn't. So that made it a pretty easy decision. Then I take that data, I train up my model, and then after that, I take my trained model and run it against my test data, which will ultimately give me some predictions on whether or not an individual survived or not. I print that out for our benefit, and then we use that to make a prediction. In this case, I'm going to be predicting whether or not a female at age 38 who paid $71 survived the Titanic. So by raise of hands, how many think that this individual survived? Yeah, that's at least what they said. I got 3 people that think this person survived. Okay. All right, and what's going to be fun with this is you actually get to see how accurate my model is. So I'm just going to run this example real briefly. What we got is a 75% accurate model. But the nice thing is this individual did survive, which is pretty accurate because I actually pulled the data directly from the data set. So I actually knew this person was going to survive from the beginning. But let's say if we change our data set here to, let's say, we're going to keep 38, but we're going to change this to male, and we're only going to pay $7 for a fare. So what would that look like? Well, we can rerun our model, and we'll find out, womp womp, this individual did not survive the Titanic. And again, it's only a 75% accurate model, but we can already kind of see the benefits of this. I could theoretically take an individual just off the street and say, hey, how old are you? And how much would you pay for a ticket across the ocean 100 years ago, or whatever it was? And they might say, okay, here's my numbers. I could say, okay, you survived, you didn't. Sorry about your life. But we can also see how this can be easily translated for other applications. It is for right now, like Titanic, but if we have another data set that is similar, maybe if you, for whatever reason, you're like, okay, I want to find out what the best route for an airplane is, or if my airplane's going to make it, not to be morbid or anything like that, but you have like a data set of like all these flights, and these are the ones that did well, and these are the ones that didn't. You can predict, oh, okay, I'm on Delta, I'm going to be fine, or I'm on United, I might have issues. Whatever it is, you can reuse this model pretty easily. So again, I did say that there's 75% accuracy here, but one thing I can do, just to show you how I can improve it, is I changed my binary classification to have a number of leaves. And there's some stuff behind the scenes on like what this is actually meaning and doing, but what we can see is by running this program with just those changes, I'm now close to 80%. So this is where that data science kind of comes in, and there's some really smart guys here at Humana. But just by understanding this type of logic behind can be empowering to you and your products, and what we can bring to our users should be and is very empowering. So I hope that was a helpful we look into what a simple program. Again, this is 100 lines. And going forward, it's pretty easy to learn. So I'm going to jump back over here. Continue. Okay. All right. So I talked earlier about that model. So there's a couple of big things that you can use to kind of say, like, I'd like to find out what type of algorithm I should be using. Again, I use binary classification. This was like a cheat sheet that Scikit, which is the main Python library people use. So I started at start, I said, okay, do I have 150 samples? Fortunately for me, I did. And then I wanted to determine whether or not I would predict the category. My case was the prediction, whether they survived or they didn't. Then I moved into the label data, and I determined that yes, I have it, and I have less than 100,000, so a linear model, in this case a binary classification, would be suffice. So that's why I jumped into that. But again, there's some other ones like clustering, or regression, or dimensionality reduction. But for this simple example, classification worked fine. Okay, so what did this newbie learn? First and foremost, it's important to know what tools we have available to us. It's important to know, just because you've heard a buzzword, what does that mean? Is it just a buzzword, or is it actually something that has some weight behind it? And hopefully from this, it's like I learned that it's not terribly hard to get into machine learning, at least to get a basic understanding. I did find out through this that there's a lot for me to still know, but at least I can start to have some informed discussions. It is a pretty easy thing to understand the basic concepts, but it is definitely a lot harder to master, and again, we have some smart people that are working on mastering this. The other thing I found out is that your test and training data matters a lot. What I didn't show is my data set of Titanic is actually incomplete in many cases. So one of the problems that my data set has is it doesn't record all the ages. And if you notice, I actually based my decision on their age. So is there a big variance in there? I'm not sure. I didn't actually run it without removing that. But cleaning that data and making sure that we're providing good data can greatly affect these models. And these models can continue to learn. An example of like why this matters is there's a group that was trying to find out if to pass a bunch of images of skin cancer holes to a machine. And they were trying to see if they could determine whether or not it was cancerous or not. And they got through the whole process, and they got their model together, and what they ended up finding out is it was a really, really good model for determining if there was a ruler in the picture or not. Because every single one of their pictures had a ruler next to the mold to indicate how big it was. Their data set was not, unfortunately, useful for their end result. So knowing what our data is and cleaning up that data matters. Last thing is that I built my model in real time. Truth is that's probably not going to happen. We're probably going to generate our models because we have swaths of data here. And it's a very, like, I only dealt with 10 or so columns with about 500 individuals, and it still was a little delayed. Put that across 2 million different rows of people with, I don't know, 100 different columns, and now you're starting to see something that takes a long time. But what's nice is we can load that model in. In many cases, it just runs that model out and generates much faster. So, here's a couple of resources I've got that will be helpful. The program, the Titanic thing that I just did, is actually on the internal human Git. So if you're an engineer or you're product or design that you want to take a good shot at trying to improve my 75%, you're more than welcome to do so. You can find it at gitcommando.io under Titanic Survival. I would love to see it. There's actually very small group that has actually got 100% prediction on it. So there's a challenge for today. We also have another example where you can go online and see how this might be used with like the ASP.NET applications. So it's actually integrated into one of those. It's cut off here at the bottom, but I've actually got that cheat sheet that I showed previously. And then I've got some of the documentation videos that I had used previously that kind of helped me on this trip to learn a little bit more about machine learning. So with that, I'm going to open the floor to any questions. Yes?
So I'm assuming you're learning this partly for Humana. So are there some projects that you have in mind for using machine learning within Humana itself, or anything you hope to do in the future?
Well,
Any ideas?
yeah, there's lots of great ideas going on right now that people have kind of thrown around. None that, in this case, I was just learning it to be prepared for when these type of things calm down. Certainly we're talking about like a lot of different options. The ideas have been thrown around as like, what could we do from a predictive model for an individual who might be, that just came out of hospital and got new medications, and how those new medications might interact with their current ones, and then predict like places that we can like intervene and potentially affect that type of change. Maybe say, okay, you need to stop taking this drug because it interacts poorly with this one, and it just be more real time for them. That was an idea that was thrown out. Another example would be something like taking an individual's previous history and say, okay, you might have a gap in care in this type of an area, and it'd be more real time. A way that we could also look at it is like drug pricing. Like, what if we can find out that by taking these two drugs together, we find that our members actually become a lot better over time. And certainly a lot of those analytics exist, but how can we start to filter this into machine learning where we can heavily use that, or just a couple of ideas. But certainly, I present this because I'd like to see what you all can come up with. There's some great minds in here. Yes?
I didn't see anything on it. You mentioned AlphaGo, and this is some odds going on. Ultimately, an algorithm is going down far enough to some extent working. Is there a thought of machine learning algorithm recognizing patterns and personally modifying itself?
Yeah, so that's actually one of the things that you see things like AlphaGo, which is Google's machine learning computer that like learns. So it actually adjusts itself by playing itself. That's actually one of the downsides with ML.NET, and this is one of the things I wanted to bring out. So I appreciate you bringing that back up. Is one of the downsides of ML.NET is right now it does not support neural networks, which is things like what AlphaGo and DeepMind require. But it's still a good and useful tool for us to kind of learn on. And in the future, because the development's so heavy right now, we will get there. But that's one thing that Python and its libraries support, whereas ML.NET does not support currently. Those type of neural networks can help with that. Certainly. Any questions? All right, I really appreciate you all coming out, and I hope you all have a good afternoon.